Our next question deals with quadratic sequences. It gives you the first 6 terms of a quadratic sequence and asks you to find the value of k. Now you might be tempted to find an expression for the nth term of the sequence, that's in part B. If you did that and then work backwards for k, subbing in n is 5, that will work for you, but because it's part A there must be a simpler way. And indeed there is. We know that in a quadratic sequence the second difference is always the same. So we're going up by 2 and then up by 4 and then up by 6. And so our second difference is adding 2 each time, so this must be up by 8, which would take me to 27, and then this must be up by 10, which takes me to 37. So I know I'm 27, because I'm doing 19 add 8 is equal to 27. I will check that using part B. Find an expression for the nth term of the sequence. Now there are loads of ways to do this. I'm going to cover first the way that I would probably approach this. I would say this is a quadratic sequence, so my nth term is going to be an squared plus bn plus c. And so my first term, so when n is 1, is 7. So 7 is a times 1 squared, add b times 1, add c. And my second term, when n is 2, is 9. So 9 is a times 2 squared, 4a, add 2 times b, add 1 times c. And my third term, when n is 3, is 13. So 13 is 9 a, because 3 squared is 9, add 3b, add c. So I have 3 simultaneous equations there, and what I'm going to do is I'm going to do equations 2 and 3, both subtract 1. The reason I'm going to do that is that that's going to cancel out my c. So 9 subtract 7 is 2, is equal to 3a add b, and then equally 6 is equal to 8a add 2b. I have 2 more equations. I'm going to solve them again. I'm going to do 5 subtract 2 times 4. So 6 subtract 4 is 2. 8 subtract 6 is 2a. 2b subtract 2b is 0. So a is equal to 1. Then I'm going to sub back into equation 4. So I get 2 is equal to 3 add b. So b is equal to negative 1. And then I'm going to sub back into equation 1. So I get 7 is equal to 1 subtract 1 add c. So c is equal to 7. In other words, un is equal to 1n squared, subtract 1n, add 7. Now that's how I would do that, and if you go on YouTube and find all those things your teachers won't tell you videos, they often have a variation of this without explaining how it actually works. The algorithm most of you will have learned, however, is slightly different. You will have been told, well, the second difference is 2, so I halve that, and that's my coefficient of n squared, so 1n squared. And then I write that out. So when n is 1, 1n squared is 1, and then 4, and then 9, and then 16, and so on. And then I do my term, subtract this result. So I get 6. So this is un subtract 1n squared. 9 subtract 4 is 5. 13 subtract 9 is 4. 19 subtract 16 is 3. And then I find the nth term of this sequence. My common difference is negative 1. And my 0th term is positive 7, so I have negative n add 7, and then I have my 1n squared as well, so n squared subtract n add 7. You'll see it's exactly the same result as we had before. Either of those are fine, and we're asked for an expression, so I don't want an equal sign in there. Either of those are fine methods. I think this is a bit easier to understand why we're doing it, but it's entirely up to you what you do. And then I said I would check k. K is when n is 5, so 25 subtract 5 is 20, add 7, 27. So I'm pretty confident in my answer. Question 20. I have a very different approach to this to the mark scheme, so you might want to read the mark scheme approach as well. I just think it's a weird thing to expect you to see, and this is indeed a weird question. A, B, C, D, E, F, G, H is a regular octagon. That tells me all these angles are going to be the same, and all of these lengths, AH, AB, and so on, are all the same length. M is the midpoint of BF. In other words, M is the centre of my regular octagon. Prove that triangles AMG and BDF are similar. Well, there are 2 ways to do that. We can either show all 3 angles are the same, or we can show that the ratio of the sides is the same. Now, just as an educated guess, probably it's angles I'm working with, because I don't know any lengths here. Now, the way I'm going to do this is I'm going to say, well, I have a regular polygon. Well, a regular polygon, the distance AM and HM and GM and FM and EM and DM and CM and BM, they're all the same. In other words, they can all form the radii of a circle. So I can draw a circle around this polygon. Now this strictly isn't in the syllabus, so you will have to explain this a bit. So M is midpoint, therefore AM equals BM equals CM, etc. Radii, so, and we would say the octagon inscribed within a circle. You could answer any, make any valid argument you make here, but then this makes it a lot easier for me to advance my arguments, because I can say that GAM is equal to FBD, GAM is equal to FBD, because angles in the same segment are equal. I can also say that AGM is equal to BFD for exactly the same reason. And therefore I can say that AMG must equal BDF, AMG must equal BDF, because the angles in a triangle sum to 180 degrees. So if the other two angles are the same, the third angle must be the same. Therefore they are similar by the argument of AAA. Now, there are perfectly other reasonable ways to do this. The mark scheme does it using lines of symmetry, but I think this is a bit easier to see, and crucially, the only reason I can draw this circle is that M is the midpoint of BF, which is the midpoint of my whole octagon, and therefore I have all 8 of my radii laid out. As I say, see what the mark scheme does as well, see which method you prefer.